Okay, we're going to start this video at number 11. So number 11, 88%. Okay, let the function be defined. Which of the following statements is true? Continuous, differentiable, interesting. It's not piecewise, so it kind of makes you uncomfortable. I'm thinking let's draw a picture. Let's definitely draw a picture, because I don't know. It's an interesting one. So let's substitute in, I think I know what it looks like. Substitute in 2, that gives me 0. Substitute in 0, that gives me square root of 2. Okay, so if this was 1 and this is 2, square root of 2 is maybe 1.4. Square root of 2. 1 gives me square root of 1, which is 1. What a weird object. Can I substitute in negatives? Negative 1. How about negative 2? Negative 2 gives me negative 4. Absolute value of negative 4 is 4. Square root of that is 2. Oh, like a backwards square root graph. Okay, that's cool. Okay, let's substitute in other numbers. I'm going to substitute in numbers on the other side. I'm going to pick another color. 3. 3 gives me 1. 4 gives me radical 2. And then what? 6 gives me 2. And there's a forward 1. And it's moved to the right. Okay. I feel good about that. I think that's undefined there. I think the derivative is undefined. So is it differentiable? No, it's not differentiable. Is it not continuous? It's continuous. So this would be false. Is it differentiable? False. It is continuous, yes. It is not differentiable, yes, because it's sharp. So I like A, but let me look at the rest. The limit as x approaches 2 is not 0. No, it is 0. If you go this way, you get a y value of 0 in both cases. So that's false, because it equals 0. Okay. Is a vertical asymptote? No, it's not. A denominator equals 0, so I don't feel like it's an asymptote. Okay, so A. Okay, 88%, that's not bad. Okay. On this one, my class did better than the overall average, but on that one question, number 9, they did worse, so anyway, it doesn't really matter. Okay, let's see. The points are on the top of the graph that satisfies the differential equation, which following must be true. Local max, point of inflection, local max, local max. Local min, point of inflection. Okay, I feel like I need the second derivative. I also feel like I can't make a number line. This is implicit. How in the world would I make a number line for implicit? I feel more like making a slope field. Okay, there's a little known rule. I don't know if you guys remember it, but there's a little known rule from AB. Okay, but it's not a rule we use very much because we like number lines at Walnut High School. I love number lines. The other teachers love number lines. But there is this rule that says if the derivative at a point is 0 and then there's 2 choices. And the second derivative at that same point is positive, and if the second derivative at that point is negative. Okay, so imagine you're concave up, but your slope is 0. So if your slope is 0 right here, what if your m is 0? The only spot it could be is right there, relative minimum. And I always draw a picture. I don't memorize this one. I just memorize that it exists, but I draw a little picture. So if it's concave down, where's the only spot on a concave down that the slope is 0? Well, that's the relative maximum. So don't memorize it, just know that it exists and then draw a little picture. That's only when the slope is 0, not undefined. So I feel like that's the strategy I'm going to use. This is called the second derivative test for maxes and mins. Now these are relative or local max and mins. Okay, so I need to set this. I'm going to need to take the second derivative here. So I am going to take the second derivative. Now this is a tricky second derivative. Now how many of you guys got this one right? 70%, you guys, you kick butt. Okay, so the second derivative here is 2x plus y prime. So the derivative of y is y prime. Think of it when you write y equals x squared. Isn't that y prime equals 2x? Yeah, so the derivative of y. So that's actually 2x plus y prime is x squared plus y. Now, I don't know if you guys got it right for the right reason or if you got it right for the wrong reason, but it's good to know how to do it. This definitely could be a free response question. It wouldn't be written this way, but it could say what happens at a certain point, and then they just don't give you a choice. They just say, is it a local max, local min, point of inflection? What is it? Okay, so they do have me substituting numbers in. So let's try it at 1, -5. And I'm going to do one color for 1, -5, and then I'll do one color for -1, -1. Okay, so the original, okay, so the dy dx, it doesn't let me write on the sides on this PDF. So let's see, where can I write? Oh, there's a lot of space there. Okay, I'm going to write down here, but it's going to be for this question, okay? So let's see if we can make sure that that looks like this question. Okay, so dy dx, this is at, and there is a notation for this. I don't use it very much, but you can use the integral notation, kind of, but it's like your calculator does. So x equals, well, you can actually put it as a coordinate. Okay, so this is a notation, or you can just use the word at. So this is 1, -5. Okay, so this would be 1 squared minus 5, which would be -4. Okay, well, that's not 0, so this rule doesn't apply. Now, it could still be, that's not a local maximum then. It could still be a point of inflection, so I'll have to wait on that one. And then is that other one a local max or local min? Okay, so let's try dy dx at the point -1, -1. So that would be -1 squared minus 1, which would be 0. Okay, so this 0 means that it's maybe a max, it's maybe a min, or it's maybe a neither. Okay, a relative max. These are relatives. Okay, so I like this one then. So I think we're not going to have to look at B. So local max or local min. So I'm going to substitute. Okay, let me move over here. I'm going to substitute the second point into the second derivative. Oh, you know what? I could just substitute it back into this one. So 2x would be 2 times -1 plus, I just found out the derivative was 0. So maybe that would be faster than substituting the other thing in. So negative. Okay, so negative means concave down. So where's the only spot on this where the slope is 0? Right here. M equals 0. So that would be a relative max due to the second derivative test for relative maxes and relative mins. Or local. Local and relative mean the same thing. So that is a local maximum, which would be C. So 12. Yeah, that was a hard one. Okay, so that is 12. Let's do 13. Okay, 13, which I don't have a lot of space for. I think I have enough space. What is the radius of convergence? Okay, so this is not on the 2020 test. But that doesn't mean that you don't need to know how to do it. So I'm going to use the ratio test. Now, ratio test is on there, but specifically it said intervals of convergence weren't, unless they've changed their minds. Which is possible. Unlikely, but possible. 2n plus 1 over 3 to the n plus 1 over x minus 4 to the 2n over 3 to the n. And there is an absolute value with the ratio test. I'm using the ratio test right now. So limit as n approaches infinity, x minus 4 to the 2n plus 2 over 3 to the n times 3 times, flip it, 3 to the n, and this would be x minus 4 to the 2n. Okay, so that numerator is x minus 4 to the 2n times x minus 4 to the 2. The 3 to the n's cancel. Let's not lose the 3. X minus 4 to the 2n. Those cancel. Absolute value, limit as n approaches infinity. Am I at the bottom? I am. Okay, so let me go left. X is actually not n. Are there no n's left? There are no n's left. That must have been geometric in the first place. Yeah. Okay, so over 3. There's no n's. So it's just what I have. And then this has to be less than 1. Okay, that has to be less than 1 because rho has to be less than 1 in the ratio test. So x minus 4 squared is less than 3. Square root both sides. Square root, square root. Technically, that gives you an absolute value, less than radical 3. And then, wow, we're really running out of space here. So x minus 4 less than radical 3, greater than negative radical 3. Oh, radius of convergence. Okay, so actually this number is the radius of convergence. I didn't tell my class that. 4 plus radical 3 and 4 minus radical 3. But if you look on a number line, okay, if you look on a number line where 4 plus radical 3 would be, and where 4 minus radical 3 would be, okay, the diameter of convergence would be the distance between them, and the distance between them is 2 radical 3. So that would be like the diameter of convergence, and then the radius of convergence would be radical 3. So radical 3 is the answer to number 13. Unless I made some error. I've been making so many mistakes on the math analysis problems. I actually messed up a formula the other day, so that was pretty bad. And then that's in my YouTube video. So that's very sad. Okay, so 13, C. That's what we got. Okay. Anyway, not on the 2020 test, unless something changes by Friday. Okay, let it be a positive integer, which is logistic. Okay, so logistic, it has to do, you're going to have something like, let me just start with these. So dy equals kt dt. This is just going to be a quadratic. Isn't that the right letter with the dt? Doesn't even need to be moved. So that's just a straight quadratic. This one, if you multiplied, you'd get ky dt. See how those are the wrong letters? Okay, so you would have to change that to dy over y equals k dt. And then I don't know if you recognize that one, but that one is our exponential growth and decay. Okay, if you don't, you could keep going and integrate both sides. Okay, this one is dy equals kt, 1 minus t, dt. Now, logistic, you get partial fractions when you're solving. Okay, so you get partial fractions. I don't get partial fractions here. I just distribute and take the antiderivative. Okay, so this one is dy equals ky, 1 minus t, dt. So that would be dy over y. That looks exponential, equals k, 1 minus t, dt. I don't use partial fractions. So this is exponential on this side. You end up getting an exponential. Not that we need to take the antiderivative here, but just so you can kind of see what I would do. Plus c. Right? And then you, remember you e both sides. You e and e. And then you get, I know this isn't logistic, but we still need to study all these topics, right? So e to the kt times e to the negative t squared over 2 times e to the c. And then what I do is I put the plus or minus and I move the e to the c in the front. And these could be kept together, maybe, the kt and the negative t squared over 2. And then I change this one into a. Okay, so this one's an interesting one. So that one we don't know. We don't know how it works, meaning we've never seen it before. Okay, so let's see. This one, dy over y. Right, dy equals ky, 1 minus y dt. Okay, the letters are wrong. That's how I recognize a logistic, is I notice that I have to bring the y's over here. And I realize, oh, I have to do partial fractions. So when I see the partial fractions over here, that's what makes me think, oh yeah, that one's logistic. Now there's other ways you can kind of memorize it, but that's how I think of it. And you know, you're not taking a multiple choice test this year. So anyway, let's see, 23%. Okay, no one remembered what a logistic was and how it worked. So that's interesting. Do I have more in the page? Let me solve it for you. Often you would just have to graph it. So let's do what if I needed to solve it. Okay, because it's possible. Probably not, though. So that would be a over y plus b over 1 minus y. There's an exam question some years ago. Well, let me not talk while I'm solving this math problem. Okay, hold on. That equals 1 over y, 1 minus y. Okay, so okay, so I usually like to find a and b later, but and take the integral first. But I would say in this case that's going to be a little strange to everyone except for my class. So let me just do it regular. So we need a common denominator. Okay, so this would be y, and that's it. Okay, so this would be a, 1 minus y, plus by equals 1. And then I like to pick numbers. So y equals 1 makes this one 0. But there's other ways. There's other ways to do this where you set other things equal. Y equals 0 would be a times 1 plus 0 equals 1, so a equals 1. Okay, let's put a big or. There's another method. You guys might like this method better where you distribute. And then you do the y squareds, the y's, and the constants. So the y squareds would be there's none. The y's would be there's a negative 1 plus b on the left side and no y's on the right side. And the constant would be the a on the left side and the 1 on the right side. And then I would get the same answer. And sometimes then you solve a system. So either way it would work on this case. Okay, so let's go back to what we would have then. I really should have written smaller. Yeah, I should have written smaller. Okay, I'm going to erase this one. So if you want to go back to this, just if you want to go back to that, it's okay. But you're just going to have to, let me erase this, but then I'm going to write that one back. You can just rewind the video. Okay, so this is 1 over y, 1 minus y. Okay, because we have a lot of work now to do. Okay, so this would be a over y, which is 1 over y, plus, I usually solve these graphically. Okay, so I usually solve the logistics graphically so that I don't have to do this. Okay, there was a problem in, I think 2004 or something. 2004, yeah, I think it was 2004, that the logistic question, if you graphed it instead, then you didn't have to solve it for real like this. And this is time consuming, so we don't really want it to be so time consuming. This one, if you pick u, okay, so if you pick u equals 1 minus y, the derivative is du equals negative dy. So you do get a negative in the front on this one. I'm in what, purple? Okay, so you get, let me erase that. Okay, so you get negative ln absolute value of 1 minus y equals kt plus c. Oops, can't fit the c in. And then remember this has to be a minus because it turns out to be a division. It always turns out to be a division or you made an error somewhere. And then you e, that's if it's logistics specifically. Then you e both sides, e, and that is, those cancel, and you get y over 1 minus y equals plus or minus e to the kt times e to the c, which would be a e to the kt is y over 1 minus y. And then they want you to solve for y. So y equals a e to the kt times 1 minus y, which would be y equals a e to the kt minus a e to the kt times y. Then you bring the y's to the same side. So y a e to the kt from the right side plus y equals a e to the kt. This is a crazy question. Okay, and then you factor out a y. So consider what I said about the graphical way. Okay, there is a graphical way to solve this. And then finally, we would get y equals a e to the kt over a e to the kt plus 1. Wow, that sucks. Anyway, so it's so fun though. It's like it sucks and it's fun at the same time. So this would be the answer, but then you would try to find a if they gave you an initial condition, which they don't in this case. So you definitely don't have to do all that. But remember this just in case. But do think there might be a better way. Okay, and graphical, where we graph the slope field and then make some decisions based on that, actually is a really good way to attack logistic problems with a graph. This one's not that case though. Okay, so let's see. Okay, is the graph is differentiable. This looks like a Leibniz, second fundamental theorem of calculus. Remember, you substitute in the top bound times the derivative of the top bound minus substitute in the bottom bound times the derivative of the bottom bound. So h prime is f This is a very good question for free response. This is a very typical free response question. I call them graph given questions. So this is very typical. Okay. Now they want to know about all these h's. Okay, so I want h double prime of 6, which is f prime of 6. And I want h prime of 6, which is f of 6. And then I want h of 6, which is 0 to 6 f of t dt. Okay, so this is a very good question to help you with free response, but in kind of a friendlier way, only because it's not a full free response question. Okay, so this is the graph of f. So f on an f graph is the y value. If they're labeled the same, it's a y value. So if the graph is f and this is f, it means find the y value. So what's the y value at 6? Okay, I would say 0. Now, f prime on an f graph means the slope of f. Now, I know it's the second derivative of h, but h isn't shown. So it's the slope of the f graph. The slope of the f graph, I can't tell, but it looks positive at the moment. We'll have to pinpoint it if we need another better decision than that. Okay, and this one, the integral from 0 to 6. Okay, now, if it's an integral, it means signed area. Okay, it means signed area, not just plain area. So from 0 to 6, this is all under. So it's negative. Make sure your bounds are right, though. Right? Smaller numbers on the bottom, bigger numbers at the top. So more area is below, like it's all below, so it's minus. Okay, so let's see. Now, the less thans are that way. So I want the negative less than the 0 less than the positive. Okay, so that would be h of 6 less than h prime of 6 less than h double prime of 6. So that would be, that's weird, they're just exactly in order. A. 76%. Okay, so that was pretty good. You guys did pretty good on that one. Yeah, logistic is your only problem so far. Imagine if there's a whole question on logistic. So we definitely need to study that one from 2004. You can look it up. I think it's number 5, because I think it's in 2004. I was teaching at Laverne at the time, and I had one BC student who was just kind of sitting in my AB class. He had been in my AB class the year before. It was their first BC student ever. And so our first BC student was in 1989. So at Walnut, we've had BC students forever. I was in the first BC class at Walnut. Anyway, so back to the guy. Anyway, he was amazing. He was like super, super, super amazing. Like, he knew everything, right? And he said that he did the logistic question the way I just showed you, and he barely had enough time for number 6. But when I went to the AP conferences the next year, they said, hey, people were stuck on 6, which was a logistic, and you're supposed to solve it by graphing. I think, like I said, I think that's 2004. And they didn't get to the Taylor series, which they knew how to do. And so they thought that was really unfair. But the point was to graph it, but they didn't say to graph it. So how would you use graphing as a tool? Anyway, so it's a good question just to look at, just in case of emergency. But, you know, the AP test is kind of on a big old curve. So you guys are going to do better than people at other schools, okay? So you're going to do fine. So don't be nervous. Study in this time. Don't be a slacker. Okay, make sure you're getting to work. Okay, 16, 94% of you got it right. That's amazing. Okay, so let's see. 94% is everybody, not just the people who uploaded already. There were 82 multiple choice people who took this BC mock. Solution, initial condition. Okay. What is the approximation Euler's method? 2 steps. Okay, I like the chart. I don't know about Mrs. Tefanction and Mrs. Herzog. I don't know how they like to do it, but I like to do a chart. So I do X, Y. I don't actually think it goes in the front. I think it just starts with X, Y. Okay, so X, Y, and then I do M. And then I do M times delta X. And then I do nu Y. Okay, and nu Y is this one, star, plus delta Y. That's actually its name. I was going to give it a funny name, but star plus the old Y, basically the new Y is the old Y plus the delta Y. Okay, and this is an approximation. Euler's method is really about a tangent line at the beginning, and then it's not really tangent lines, but it is equations of the line. Now, it says 2 steps, so I think that we're going to need another row. So let's see. It says they gave me 1, and they want me to find two equal steps. So that would be 1.5 and then 2. And then they want this number. They do not want the rest of it. So let's cross that out at the beginning. So the y value is 3. The m. So the m would be dy dx equals, this is an x, is 1 minus 3, which is negative 2. So the slope is negative 2. And then you would multiply that by delta x, which is 1/2. Delta x would be this, 1/2, 1/2. And that's just because I tried to make it so there were 2 steps. Those are the 2 steps right there. So that would be negative 1. I usually leave more room in that section. And then you take the y, so let me highlight it for you. Not highlight with the eraser, but that's where my highlighter is on my other app. Okay, so this is, you take the old y, and you add this negative 1. Okay, that's how you do Euler. So that would be 2. Oops, that's still my highlighter. Okay. Okay, so this is, hold on a second. Okay, so this is 2. Wait, let me get the pen. So this is, I'll put 3 plus negative 1, which is 2. Okay, and then this number gets put over here. So I'm going to highlight that for you. Let's see, we'll highlight in green. Let's see if that works. So this one is this one. Okay, it just moves over to that spot. And then you repeat. Okay, and you guys know this because you kicked butt on this question. 16, 94%. So most of you know this. Okay, so, oops. Okay, let's try that again. Okay, and let me erase and then go back. Okay, so dy dx this time. Now that first one was a tangent line, but this one's actually not a tangent line anymore because 1.52 is only an estimate, so it's not really on the curve. 1.5 minus 2 is negative 1/2. So this is negative 1/2, and then negative 1/2 times positive 1/2, which is negative 1/4. So then I'm going to add my 2, my green 2, plus my negative 1/4, and I'm going to get 1 3/4, which is 7/4, which is the answer that most of you got. That was the answer. Power series converges to which of the following? Okay, so this is actually asking for a Maclaurin. Now it is a Taylor. Power series just means it's powers of x. It's Maclaurin because it looks like 0 substituted in would be for x. So cosine x, so that would be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial plus ... That's not it. Okay, sine, b. Sine is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial plus ... Not that. Looks like that, though. Oh, I like C. Because to do C, let me do C on top of B. What if I divided by x? Ooh, I like this one. I think this is the right answer. So that would be 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial plus ... Okay. So it's that one. I'm satisfied. I'm just going to pick that one. 77%. E, just to remind you, E is all positive terms. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus ... And then e to the negative x is the same thing, but with alternating signs. And then we don't know if you're going to need these because technically they took Maclaurin off, but they left Taylor on. So, I mean, these are Taylor series. And then there's tangent inverse. Tangent inverse looks like sine, but without factorials. Oops, not a factorial. And then there's, what else do you need? You need 1 over 1 plus x, which is 1 minus x plus x squared plus, minus x cubed plus ... And then 1 over 1 minus x is 1 plus x squared plus x cubed plus ... And then also ln. So you might need to know ln of 1 plus x. And ln of 1 plus x is actually the antiderivative of this one. So I don't know how you remember it. And then when you put the plus c, it turns out to be 0. So it's x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4, but there's no factorial, so be real careful not to put that on. Okay. Let's go to the next one. 18. Okay, I'm going to call this a graph given problem. It's a graph given of f prime. So let's see. My mom is texting me, where the heck am I? Because it's dark. It's over here dark. It's 8:32 and I'm up here by my pool looking at my view over my house because we've been inside so long. Okay, so let's see. The graph of f prime, the derivative of f, consists of two line segments. Okay, so those are lines. And a semicircle. Okay, shown above. F of 2 is 1. What's f of negative 5? Okay, this is my height thing, my accumulation function. So the height at age b is the height at age a plus the integral from a to b of height prime. Okay, so you can do it with f's. Now, I like to put my bigger one on the left. So f of 2 is f of negative 5 plus the integral from negative 5 to 2 of f prime of x dx. Now, I think there's another way to do it. I think Miss Tefenction sometimes does it the way I just did it, and then sometimes she says, well, what's the antiderivative? And then she says it's f of 2 minus f of negative 5, right? Because you would take the antiderivative and substitute the numbers in. So either way is fine. It's the same equation. If I move this over, then I get that equation. There's two different ways, and you're going to see it both ways in the free response solution. So both ways are good ways. Okay, so this is 1. And then f of negative 5 is what I want. But you know what? I know how to solve equations, so I prefer just to go in order. I don't want to go weird and backwards. Okay, the integral of f, this is the graph given, right? GG is initials I have. So this is the given graph. So you don't want to put GG on your test. Okay, so it is the integral, but it's the signed area, right? It's the signed area because it's an integral. It didn't say area. So from negative 5 up to 2. Okay, 2's right here, so I don't want this spot. So this would be 3, and that's 2. So that is the area of a triangle, 1/2 base times height, and that's 1/2 3 times 2, which is 3, and that would be positive because it's above. And then this is actually a semicircle with radius, what, 2? Let me change colors on that so you could see better. So this is radius 2. And then a circle is pi r squared, so a semicircle you would divide by 2. So that would be pi 2 squared over 2, which is 2 pi, but negative because it's below. Okay, so back to my integral here. This would be f of negative 5. Oh, let me make myself have some space. So this is f of, oh wait, sorry. I'm trying not to make careless mistakes. I rely on my class to catch my careless mistakes, and so I can't do that here because they're not here. It's so sad. So 3 plus negative 2 pi, because that does count as negative. And then f of negative 5, you're going to move that over, what, negative 3 and then plus 2 pi. So negative 2 plus 2 pi is f of negative 5. 2 pi minus 2a, 55%. Okay, so a suggestion. I feel like a suggestion would be this. I really feel like it's important that when you set them up, that you set them up in order. So you can think of your age at 18, your height at 18 is your height at 0 plus 0 to 18, and then they go in order. Okay, or 17 if you're 17. And then that might help you set up the equation. Okay, or maybe you didn't remember how to do it at all. Okay, so let's go to the next one. Okay, number 19. Number 19 is a 76%. The function is defined by what point on the graph is the property that the line tangent. Okay, tangent. How'd you guys do on this one? Unless it was a tricky one. 19. 76%, oh, you already said that. So slope is a half. Do I know the slope? No? Tangent? Not normal, right? Okay. So let me take the derivative. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So that's x plus 2 minus x over x plus 2 squared. So chop chop, 2 over x plus 2 squared, f prime of x. I'm probably writing way too big. Has a slope of a half. So that's the slope of a half. So that would be cross multiply, right? cross multiply. 4 equals x plus 2 squared. Oh, did you mess up when you square rooted both sides? Did you forget your plus or minus? Now, technically, there's an absolute value over here, which is important for other questions. But probably what you forgot was the plus or minus. Now, if this was a greater than sign, you need the absolute value. Or if it was area, you need the absolute value. So I highly recommend the absolute value. And then what is that? X equals 0 and x equals negative 4. So there's 2 spots. Ooh, there's no such points. I don't know. I'm not going to risk it. So I'm going to check. Oh, caps lock on. Hold on. I am going to check. And I need to make sure that these x values are legal in the original equation. What if negative 2 was one of my answers? And then I'm not allowed to plug in negative 2. So that'd be kind of a concern. But I am allowed to plug in both of those numbers. So when I substitute in 0, I substitute it in, I get 0 over 2, which is 0, 0. And let me just kind of block this out. And then negative 4 would be negative 4 over negative 4 plus 2 is negative 4 over negative 2, which is 2. So that would be negative 4 comma 2, which are the points they said, which is C, which is the answer for this one. Okay, number 20. Number 20. Okay, now this does make me a little bit nervous because when I was your age at Walnut, the thing I missed in AB was I forgot the absolute value on the square root, that step right above. So that's interesting that these 2 questions are here. And then on the BC mock, what I forgot is I didn't notice that there was a domain restriction. So if this had said, say, if this had said negative 4 to 0, would you have noticed that there were 2 spots that made it an improper integral? Okay, now it doesn't, but it makes me nervous. So I don't know if it's an AB question or a BC question. If it's a BC question, it might be an improper integral. Okay, so it is not an improper integral, right? What are the problem areas? Negative 2, negative 1. So I'm okay if I'm only going from 0 to 1. Okay, so why is this on the BC test? This looks like it's a, it reminds us of the one we just did, the partial fractions one. Okay, so this is 5x, hold on, let me get back to my pen. So 5x plus 8 over x plus 2, x plus 1 equals a over x plus 2 plus b over x minus 1. On our test, we won't have a squared, but if you did have an unfactorable quadratic like that in college, you would put cx plus d. Okay, but that's not going to be on this test for you. Okay, it's just linears. Not even repeated linears, just regular linears. But we teach it too because we want to make sure that you know what you're doing for college. So this one, I like to show my common denominator. That'll really help in college in case some things get weird. If you have any of these, x plus 2, x plus 2. So this is equal to ax plus 1 plus b parentheses x plus 2. I do like to do the substitution of the x equals negative 1 and the x equals negative 2, but I think most of you do the multiply out way. So I'm going to show you the multiply out way, even though I don't really like this way. It's good for other things. X squared, x, and constants. X squared, there's none. X's, I get 5 equals a plus b. And for the constant, I get 8 equals a plus 2b. And then I need to solve the system. So a plus b equals 5, and a plus 2b equals 8. Let's distribute a negative on the top or the bottom to get rid of the a's. So you add them, and you get 1b equals 3. And now that b equals 3, you can substitute that in, and that's 5 equals a plus 3. So a equals 2. So a is 2, b is 3. Okay, I need the integral of a over x plus 2 and b over x plus 1. Now, because sometimes a and b are fractions, I usually do the integral. And then substitute the a and the b later, especially in case you make a mistake in finding a and b, and you know that you're going to be taking a free response, and that's partial credit. Okay, so what if those were fractions? They're not, so it's okay. And then the only reason I got this is because I was doing u sub. So u is x plus 2 and u is x plus 1. Oh, do you see this answer here? Divergent? This is not the answer, but divergent would have meant it was an improper integral, and maybe you got infinity as an answer. So maybe you would have gotten infinity. So that's interesting. Okay, so this is a BC question, or divergent wouldn't have been on there. Also, partial fractions is BC. K plus b, what was b? 3? ln x plus 1 plus 3. Oh, and I have to plug in numbers? Oh, that's annoying. I love it though, but you know, I'm a little limited here. Okay, on my space. 2 ln 3 plus 3 ln 2 minus 2 ln 2 plus 3 ln 1. Okay, ln of 1 is 0. So that would be 2 ln 3 plus 3 ln 2 minus 2 ln 2. Well, that's 1 ln 2, isn't it? That's like terms. Look, there's all like terms. And that's 2 ln 3. Okay, now that would be fine on the BC test, but that's not the answer on our test because this is multiple choice and I need to match that. So let me write that up here. 2 ln 3 plus 1 ln 2. So let's draw a big arrow. So we'll draw a big arrow up here so you know where it came from. Okay, and then you could change it to this. And then remember, ln's of pluses change 2 times. So that's the ln of 18. C. Let's see. And then I am getting a little chilly out here. So I think I'm going to go back into my house where my mom is probably thinking that I'm breaking our quarantine. C. C, right there. We're not really in quarantine, but my mom is 75 quarantine. So she gets a little nervous if I leave the house. So I only left the house to come into the backyard. Oh, is that a spider again? Oh no, that's a cool little thingy. I don't know what that is. What's this one? Oh, no. Oh, shoot. I keep missing them. Okay, so ln of 18, the end. Okay, I'll upload these, and then the next one will be 21 through 28, but I might save that for tomorrow.